SuperCloud Composer's Monitoring Detail module offers rich out-of-band analytics and telemetry from a monitored host BMC interface. Within SCC's architectural framework, a collector service harvests metadata through redfish queries and publishes its essential sensor data in the form of concise charting and graphs. Administrators will receive up-to-date intel to make their data-driven decisions without hesitation. Let's uncover how administrators can obtain such intel. So here we have a monitoring detail module that's been launched. It's at the pod level. You can see here where we expose at the carousel view a cumulative of resources. We have critical pod health. We have systems of 28, switches of 7. So really a collection of resources in the carousel view. We give you the ability to look back in time based on a date picker. You can plug in the dates themselves within the schedule and then go ahead and do historical trending. The system status can be provided in the form of health and actually power itself. So on the health option, if you click on one of these red entities or green entities, you'll immediately be linked to the monitoring detail for that particular BMC event, whether it be an event that was reported as good health of the server, warning, or critical, and you simply would click here on this particular link and it would immediately take you over to that BMC event at that date and time when that basically occurred. The other thing I want to show you is that you can actually, by the mouse wheel, scale in and scale out the various different types of tracking that's done within the system status. We also provide you with performance data here below as far as training is concerned, average I/O bandwidth, memory percentage bandwidth, processor bandwidth. So again, the same rules apply. Things are placed in the foreground and background depending on what type of feature or information you're trying to collect from the performance charting section. So we also want to go ahead and click on the navigation view, which actually opens up a sidecar information at the pod level. So you can go ahead here at this point and click on Compose Node. You'll see Compose Node information. Again, the same rules apply as far as hovering over each one of the data elements. So we see here systems that have been allocated, are assembling, ones that have failed and been degraded. We also provide you available drives at the JBOF storage at the pod level. So if you had a number of JBOFs that were out there within your fabric, we would expose the available drives. In our case, we only have one JBOF, so we're only reporting on available drives for that specific storage system. We also provide you with power supply information at an aggregate pod level. So you see here where we provide the sum of capacity wattage, sum of output watt, and sum of server consumed watt. So these definitions are very much detailed in the documentation of SuperCloud Composer and the end user guide. So to look at definitions of each one of these and what they pertain to and what they mean, you can actually reference the user guide. So again, here we have temperature associated with inlet temperature within the drawer or at the chassis level of the server itself for each particular server chassis that's within our pod. So let's go ahead and cycle back here and click on the tree option, and let's really look at the chassis level of this 4-node multi-chassis big twin. So if we click at the chassis level or at the drawer level, we will be provided with status for the 4 nodes. And by clicking on each one of these particular nodes, you can go in and look at more detailed information. This is our performance type of data for the entire chassis node itself. We have also a carousel view of resources that are available specifically with that chassis. And then we also provide you with, again, a date picker to go back into historical trending and historical time. So if you click on the 5.12 system, let's use that as an example here. We're looking at data and analytics and telemetry specific to this system, which is 5.0. It's one of the nodes of the system. It's in the A node because it's showing up as an A location here. We can also look at power information and health information. We provide, again, a carousel view for resources specific to that node. You'll see here we also provide BMC event data, which is MEL and cell information that's harvested and collected from the BMC, which is our source of truth. And we can also click on the option here at the navigation view, where we can go ahead and collect detailed information about this system, such as processor bandwidth. We can look at metrics associated with the CPU, different NUMA regions that can be supplied here for analytics and telemetry, such as consumed watt, temperature. And again, if we want to change the NUMA region or look at different information, we can go ahead and change the CPU here. We have health event information here available to you at the bottom. And on the memory side of things, we can click the memory option. When we click the memory option, it provides you an aggregate memory for each of the regions of the CPU itself. And then we also provide you with, very interestingly, DIM information for DIM temperature. So again, memory total consumed wattage, the temperature of the DIMMs themselves, and then we also provide you with health event information here below. So if a DIMM was to exhibit any type of failure or an ECC type of error, we would provide this information in the message area here and basically timestamp it. So all in all, very good intel that a architect, server architect, or administrator can look at to really look at making and driving their data-driven decisions here and investigating different pieces of analytics and telemetry that'll be very helpful for their day-to operations.